So my name is Matt Stephenson, of course. I'm a senior principal software engineer at Starburst. I lead infrastructure there. A little bit of trivia, I overlapped with Spencer and Peter at Square. So I learned about Cockroach very early on. So I was incredibly excited when David was equally excited about it. I started our kind of like virtualized internal CRDB team, and I think it's important to note that it was more of a virtualized team because we've never really had to create a dedicated manager and set of folks that are always 100% working on Cockroach. And that's like a real big change from my past experience at other companies. Prior to my experience at Starburst, I've worked at Amazon, Google, and Oracle working on their cloud platforms. So there's a lot of similarity between like how we built Galaxy and how those cloud platforms are designed. So Trino is what Starburst is built on top of. And yes, I did train my dog to wear hats. It's a fast distributed SQL engine that's designed for big data analytics, different from Cockroach in that it's, we're not looking for like sub-millisecond performance or microsecond performance on queries. We're looking for like being able to crunch large amounts of data with a very large distributed cluster of machines. It was open sourced at Facebook in 2013 as Presto SQL. We renamed it to Trino in 2020, forked it out, and all of the contributors and the founders now contribute to the Trino project, or all the major contributors. And it's used by hundreds of organizations across the world. We try to get the cluster as close to the data as possible because that's going to make a big difference in the performance of being able to pull from, like, say, S3, from Iceberg running on S3 or Delta. And it's going to really make and these days we're actually trying to get like so close that we're not just in the same region, but if you look at S3 Express or some of those technologies, we're trying to get in the same availability zone as where the data is being hosted. So I'll give you a quick demo of Starburst Galaxy. So just taking a quick overview of it, we've got like a cluster running here. This is kind of like the main screen you'd see. This is the data that we store in CRDB. This is how a customer would create a catalog or view some of their existing catalogs. So just real quick, I'll take you through some of the flows that like a customer might do. I don't want to take too much time on it, but we have a plethora of data sources that you can attach to via our catalog system. All of this is stored in CRDB, including the credentials. We encrypt them using KMS. Iceberg is probably one of our most popular formats. We'll run a quick query. This is just against a demo data set. You can select your cluster, your schema, and your database. I don't know why that's timing out, but we'll just go on ahead and run the query, get the results. So this is a running cluster. If we have a cluster that's like suspended, it'll actually shove that query into a CRDB table that's regional by row and pull that result back out and send it to the server once the server starts up. So it's seamless for customers whenever we kick off queries. And of course, this is just using the in-place edit, like the in-browser SQL query editor. Like we have most of our customers go through our APIs. Just real quick, showing you like our whole RBAC system that we've built allows you to define users, groups, and roles that you can constrain access to your clusters, your data sources, and even to finer granularity than that. So all of this is running on CRDB. This is running with global tables that are replicated across multiple different regions. And then we basically read across all these different regions to make it really fast for Trinos to do RBAC checks. And writes go back to a primary region so that we can keep all of the RBAC system as consistent as possible. We always want to make sure that, like, when someone denies a grant, it's immediately denied across globally. The audit log is another piece of functionality that runs through Trino, or runs through Cockroach. All of that is, of course, is super useful for auditing events that happen through the UI. Query Insights, our query history product, this is actually like the heaviest use of Cockroach that we have. It's the majority of our data. Whenever a query is executed, as you can see, there's a lot of data here. Whenever a query is executed on a Trino cluster, that query event ends up getting ingested back through our event bus into Cockroach, And this is like one of the biggest, heaviest weight uses of Cockroach that we have. And I'll go into that a little bit later in the slides. So how did we build this thing? We built it all based on Cockroach from the beginning, and Cockroach Cloud. So we're not running it ourselves. Our control plane runs in only in US East 1 primarily. We can easily fail over to US East 2 if we have to. That's just like mainly like the user experience, and a lot of our asynchronous jobs run there. Our data plane is structured such that for each cloud region, we can run multiple of these Trino planes, which is where Trino clusters actually run. And then we also run a singular services cluster, which gives us a lot of our substrate services that Trino depends on. And we do this so that we have isolation between all of the services that support Trino and a low latency regional capacity, and all of the workloads that are running in Trino planes. It allows us to isolate those networks apart. It's very similar to how AWS works and like other cloud products work under the covers, where you have EC2 running and there's a metadata service, right, that you can reach from within an instance. That metadata service, the actual service that's hosting that, is on a separate network than, say, any network you're able to touch, possibly from within an EC2 instance. So we like to keep that security isolation there. We have some services clusters that run in regions that we don't have Cockroach. Those, there are certain services we exclude from those regions, and we proxy by HTTP over to the region where we have a CRDB replica. And in some cases, we just connect to CRDB cross-region. So I'll get into that a little later as well. So why did we start off with CockroachDB? Well, this is a slide that mostly I didn't change from David's talk because it's been true for 3 years. We've had no major downtime or data loss. We've had hiccups, we've had bumps, we've had things that we needed to work with support to improve the experience that our users had, but we've never really had like a massive major outage. It's always been available, and it stays available even if we take out like US East 1. Everything just fails over to US East 2 because we have regional survival goals. So it's easy for us to adjust the regions we're deployed in. So I'll go into that a little bit later as well, but we will spin up additional regions to support customers as we go into additional cloud regions with Galaxy, or we have a large interest in those cloud regions from Galaxy. And that allows us to just basically support customers across every single cloud provider we're in and all the regions that we're running in. Development. It's sped up development substantially for us. It makes it so that like anyone who really understands Postgres can come in and work in our code base. We have a bunch of check style rules to make sure that people are following correct code style guidelines. They're not doing anything too crazy with the database. Those are kind of normal, I feel like. There's not really too much extra that we do with CRDB. There's some thought with multi-region tables, like global tables versus regional by row tables, and some of the modeling and how foreign keys work. But all of that's become really simple. We leave a lot of that to the development teams to figure out. I myself or David will do like a lot of reviews if it's more complex, but it's 3 years on, it sings through the development process. We're really robust against bugs in application code because we don't have to do a lot of specialized like conditionals based on sharding. I remember working in like Vitesse for years, and there's so much code in there that you really have to like, there's so much on top of like just writing a SQL query you have to do to figure out how to deal with the shards and such. And of course, serializable transactions globally just makes it very simple for people to reason about, and they don't really introduce a whole bunch of application bugs. From an operations perspective, we love that like we can just let Cockroach Cloud handle this. They run it, we don't have to worry about it. We've had a few like hiccups with like making changes to the cluster, but we've actually been able to engage support before anything bad happened. And I actually once changed our regions around, and like we actually stopped it and fixed it before I knocked out US East 1. I kid you not. And so this really allows us to like upgrade and evolve our software with Cockroach really, really rapidly. Like we're on 24.1 already, I think, and we we love it. It allows us to do online schema changes without having to worry about like taking downtime at all, of course, and we can always transparently scale to larger clusters. Someone else recently bumped up the size of US East 1, and they didn't screw it up like I did. So it went wonderfully well. So what are some lessons learned over the last 3 years with Cockroach? So like I said, we have this broadly deployed multi-region CockroachDB. We're running in 25 different cloud regions across all 3 cloud providers, GCP, Azure, and AWS. We have our replicas distributed such that from any one of those 25 regions, we're within 40 to 80 milliseconds round trip from any of those internal services, like I was describing on the substrate or services plane. This means that we had to take a lot of like planning around this and try to figure out what our SLAs were with specific customers to make sure that we had regions more on the 40 millisecond side versus the 80 millisecond side. But it's really awesome because we can just kind of add additional regions, and we've actually also taken regions away. It takes a little bit more work to take a region away, especially with regional by row tables, but we've done it successfully with no interruptions. In some cases, what we do with some of our services that have to do reads and writes for global tables and regional by row tables, we actually set up 2 different paths for writing and reading. We've done this both from client libraries and from within the service, where we set up a connection to both the regional instance of CockroachDB, and we also speak remotely to the primary instance so that we're pushing changes for global tables directly there instead of proxying through the cluster. One additional point. We have a really broad distribution between our 2 from US East 1 and Singapore, AP Southeast 1. We actually, to support that and some additional regions, we slowed down our writes a bit. And that's like one of the only flags I think we've ever set. And that's really improved overall experience, because even though it takes a little bit longer to make a write, with our architecture, we're not dependent on rapid writes necessarily. So it allows us to give a really positive experience to our customer from a read perspective, and we just have to be conscious that those writes are just going to be a little bit slower, and we've been able to work around that just fine in our own software. So another lesson learned was that we really had to adopt PrivateLink. We pushed it off for a long time, but with Cockroach Cloud, I would say that PrivateLink is probably what you want to try and do. It gave us a really great path to meeting compliance and security goals, which was our original interest in using it. But we also learned that it improved our database connectivity substantially, because it skips over the NAT gateway on the way out from our VPCs, and it skips the NLBs on the way in to Cockroach Cloud. So it's a lot faster from that perspective, and much more reliable. We have to solve kind of inter-region connectivity ourselves. So like I was saying earlier, we have some regions where we run our data plane that we don't have a CRDB replica. In those regions, we have to support private networking from one of those non-CRDB regions over to a CRDB region. We're working on using Istio Envoy for that, and it's been really successful. But I would say that like if you're just in AWS, something like inter-region PrivateLink or transit gateways would likely work as well. We've tested those out a little bit, and they seem to be just perfectly fine with our load testing. Schema migrations, we've learned a lot about. We're Java shop, so we use Flyway. David added support for CockroachDB to Flyway, so those are a couple repos you might want to take a look at if you're a Java shop. Validating all the migrations takes a bit of time. So what we did was we eventually, like when we got to like 200 migrations, this isn't really like specific to Cockroach, but it's something that's a great idea in general. But just kind of like we came up with this kind of concept of a baseline DDL and DML that we apply, and then that from there on we apply migrations. So, and we also have a hash that we check in with our source code that we verify the DDL and DML files that we're about to apply with that hash, just to make sure that nothing broke in our build process. Some just minor gotchas that we've learned to do, some of our own internal checks when we're doing a pull request is don't mix DML and DDL. Just don't try and do them in separate migrations. Only do one altered table statement per table per transaction. So kind of keep those, at a small granularity. Use separate transactions at all if possible. So what that means is what all of this means is we've created a situation for us where we always have to support forward compatibility of migrations relative to backward versioning of the software. So we always make sure that in our CI process, we're looking to enhance this. We do some of this today, but we take our running system and we verify it with migrations as we're applying them to make sure that somewhere in the middle our software doesn't break, right? So that's a good, keeping it really granular means you also have to eat some of that CI work, unfortunately. So I'll talk real quick about that query history feature that I pointed out earlier. This was the biggest kind of hiccup we had early on with working with Cockroach. It's a huge table. It's 90% of the total database is in one table. It's basically Trino emits these query completed events that have a lot of telemetry data. They have the query itself. They have a whole lot of additional information about the query, the explain plan, and things like that. And those get shot into a Kafka topic, which then goes through replication and everything, ends up on our control plane, and is ingested into the query history table. That ends up driving the user experience. It also ingests into Iceberg. So what we found out was that with this specific table, and it's actually three little tables, it's one big table, two little tables, we move those to its own database, which then we can kind of we don't necessarily need regional survivability for the query history feature, so we kind of shut that down. It's okay, if we're in that bad of a state, we can have a little bit of delay in query history, or maybe it won't show up for a user. And also backups. We didn't really need to do backups as much for that, right? Because we were already pushing that into Iceberg so that customers could go and query it through Trino and see some of their more advanced chunks of those query history events. They include a lot more information than we actually persist in Cockroach. And so that really allowed us to scale up and grow that data even further. And it made it, also breaking it out into its own separate database, that also made it a lot easier for us to expire older history. It gave us a certain amount of isolation that we weren't bumping into a lot of foreign keys when we were trying to expire old query history. So that's what I've got. I'm here for questions.
Great presentation. How big did you let the query history table get before you knew you were in trouble?
1 terabyte.
Okay.
It's 2 terabytes now. But that was 1 terabyte without us trimming a bunch of columns. So yeah, it's probably about 5-6 times as many rows.
Can you tell us more about the PrivateLink, and have you seen any limitations around it, like any upper limit that you have seen with PrivateLinks?
PrivateLinks worked really well. It's improved the reliability substantially. It did take a little bit of work to get it set up at first. There's some neat features that, first time we went around and tried to set up PrivateLink, Cockroach didn't have, I think it was a mix between Cockroach and AWS with some of the DNS tricks that you can play with now with how PrivateLink works. These days, Cockroach pushes through the VPC, endpoint, private DNS entries that make it a lot easier to utilize. Prior to that, you had to kind of maintain and deal with some certificate stuff. But now it's super simple. It was really easy to set up. We have it all automated now through Pulumi on all of our deployments, and it just gets deployed. if we have kind of like a map of these are the regions that we have CRDB, and so whenever we do a deployment of one of those regions, it just automatically verifies the private links there. If it's not, then it adds it. So if I were to add like another CRDB region, our deployment automation would just go detect that, drop the private link in there for us. It's nice.
Yeah, two different questions. The first one, you mentioned that mistake you almost made.
Yeah.
So I'm trying to get a sense for it sounds like there's some collaboration between you using the cloud service and between, did Cockroach Labs catch that before you did? Or how did that
No.
Okay.
Yeah, no, I messed up using the UI, I think.
Okay.
And it started to make changes. And I opened a support ticket, and I was like, maybe this is a P2. And then I realized, no, this is a P1. And they got back in touch with me quick enough that we stopped the operation, and everything went smoothly, and we got back to a stable, sane state really quickly.
Okay, glad that worked out. The second question was about the slowing down the writes. And I'm just wondering what led you to the point of realizing you needed to do that, and then how did you do it?
That's a great question, because I forgot to mention that when I had the slide up. It's probably why I got done so quick. So what ends up happening is that we were writing to US East 1 for a global table, right? That was the primary region. We had a replica of that. We have that table also, because it's global, it's available in AP Southeast 1. All of our queries for reads to AP Southeast 1 would take forever. That's how we first noticed that there was a problem, right? So we had a high latency just on that specific, on one specific table that we were writing to very quickly. So slowing down writes all of a sudden started to speed up reads there, because the visibility of that write occurring, that write was not actually visible within, I'm blanking on the name of the flag at the top, off the top of my head, but there's a visibility guarantee for a write to occur. That write was not visible within AP Southeast 1 because of the total, like the speed of light between Singapore and Virginia.
That was part of my question as well. But the other one I had was, it sounds like you chose to use Istio Envoy maybe because you had an agnostic environment, or
yes.
Okay.
Yeah. So we were running in Google, Azure, and AWS, and so we wanted something that just deployed into the Kubernetes cluster itself.
Got it. And that was your reason for not using inter-region PrivateLink, being an AWS native tool. Cool. And then my other question was, how did you go about, because we've actually hit the problem of just load testing, how far do you push load testing within your Cockroach environment, or how do you go about doing that today?
Yeah, we do need to do better with load testing. I'll say that. we have like this awesome query history table though, so we can just kind of like replay our entire query history table and even event stream just back through the front door of our, it's basically our request routing system, our dispatcher. So what we can do is just select all those queries that we've maybe ever run in our dev or demo environments and just push them directly through the Trino client into the front door on the dispatcher. That lets us really kind of like slam a bunch of queries through at once. There's other load testing that we've done with Gatling and other tools in the past. And we have an entire performance team that has benchmarking load tests that are more like, so with our platform, we kind of have like, think of it as a couple different types of load testing. We have load tests that hit our public APIs really hard with high levels of concurrency. We have a lot of concurrent queries, trying to increase the amount of concurrent queries that are executing. The first one, of course, is going to directly do reads or writes to CRDB because all of our public APIs are backed by Cockroach. The second is going to be, a lot of that is testing all of the service plane calls, like like Trino's reaching back to the service plane to do RBAC checks, or it's doing some other check to figure out how to run the query. And then the third one is basically like, those are more like just raw Trino performance benchmarking tests. So they don't really hit Cockroach as hard, but we've got like kind of we have set data sets and set queries that we run on a regular basis to benchmark our own performance in our SQL engine.
You mentioned you use global tables a lot. And as far as I remember, when you have to restore a global table from backup, you need to restore into a multi-regional database with all of the existing regions. Did you work at solving the problem of losing a region and having to restore backups at the same time?
We haven't had to solve that problem yet. So, yeah, we should maybe chat offline about that one because I'm curious. I want to make sure we don't hit it. All right, awesome. Thank you very much. I'll be around for questions, so just find me.